Hi, welcome to the Aruba OS 8.3 how-to video series. This is the 8th video in a 15 video series that covers the initial config and deployment of an Aruba OS 8.3 Mobility Master deployment. Now, this video is going to focus on the creation of a controller cluster underneath the Mobility Master. And from previous slides, hopefully everyone has seen or watched or learned of. In Aruba OS 8.x, we support the creation of controller clusters to handle things like stateful failover for clients between the controllers, as well as support other advanced features like doing live upgrades. Now, to establish the cluster, we need to put some configuration elements under the MM because the MM is the cluster manager, and then we need to tell each mobility controller what they're going to belong to. But before we can cover what that is, I want to talk about what it entails, or at least what is required. Now, for this one, we're going to do VMC A1 and VMC A2. And so we've already established the VRRP between the two. We're going to use this for things like AP discovery. And then we obviously have an IP address that resides on each virtual mobility controller as well. What needs to be added to this, and this is a little bit new, specific to a cluster config, is that we need to add a change of authorization or a COA virtual IP that can be used by the Mobility Master and the Radius servers. And the reason why that is let's say I have a user that authenticates to VMC A1, and that authentication is handled through ClearPass, and ClearPass sees the IP address that asked for the authentication, which is VMC A1. If during the process of that client's session he gets moved over to VMC A2, and then we need to send a COA, without this COA virtual IP address that is established on these clusters, the ClearPass would just send it to .61, and .61 would say, I don't have this user, and it would get dropped in the bit bucket, and so the COA would never succeed. So what we do is, because within the cluster they have a COA IP, they are aware of when a COA comes into one of these IP addresses and can forward it to another controller. And so, in effect, we need to establish the IP address that's used by the controller to talk to the network. We also need to create a virtual IP that exists primarily on VMC A1, which is going to be .63, even though they're both aware of it, so that if this controller goes offline, he can receive the COA, or if the user gets moved to another VMC, he can also receive the COA. So that's why we're going to establish what looks to be a lot of IP addresses, but hopefully that makes a little bit more sense. But if you need more information, you can certainly read about it in the user guide. So in effect, for every two controllers, for these two controllers, we're going to have a VIP that is shared between the two controllers. Each controller gets his own IP address, and then as part of the cluster config, each controller also gets their own VIP. So when we go through the setup, this is what we're going to see. So I'm going to start with Campus A. We're going to do Campus A through the GUI. I'm going to do Campus B through the Aruba Solutions Exchange as a demo for ASE and kind of show you what it looks like from the command line perspective. Now from Campus A, we go to Config and Services, and you can see that we're in the Cluster tab now. So I'm going to create, under the Mobility Master for this group, and we're going to just call this Cluster A. We'll call this Campus A cluster. That'll work. So I'm going to add the first controller. We're going to use IPv4. I'm going to pick 61. And now you can leave the group as none. The group discussion is more of an advanced topic, but certainly reach out to community.arubanetworks.com if you have questions, and we can talk about what the group assignment actually means. But for the purpose of this demo, we're going to leave it as none. I'm going to define the priority, let's just say, as 200. I'm not going to do, we'll go ahead and enter the multicast VLAN, that's fine. That's going to be for Campus A, VLAN 200. Now looking back at our drawing, the virtual IP for the cluster is going to be .63, so I'll do 192.168.200.63, and then the VRRP VLAN for that is 200. I'm going to hit OK, and I'm going to add the other controller the exact same way. It's going to be IPv4. I'm going to leave the group as none. This priority will be 200 as well. And then the MCAS VLAN is 200, just because I'm putting everything on the VLAN. If you had a specific multicast VLAN that you needed to include as part of the cluster, you could include it there. This controller's IP is going to be 200.64, so it's 192.168.200.64, and this is going to go in VLAN 200 as well. So I'm going to hit OK. Now there's some other settings that you could tweak down here. We don't generally recommend that you do so unless you're told to by TAC or it's part of a VRD. But in general, you would basically want to leave these alone. We're going to hit submit. Now what this has done is this has essentially created the cluster profile, and this tells the mobility manager, or sorry, the mobility master, which controllers are a part of the cluster and what the cluster settings are. Now what I need to do is I need to go into each controller and tell it which cluster to be a member of. And so I'm going to choose the Campus A cluster. Now the one thing to be aware of with clustering is when a cluster is established, every VLAN that exists on that controller needs to be able to see the other at layer 2. And the reason why that is because we're using VRRP to establish a lot of the mechanisms on how users and APs are balanced across the cluster. So if there is a VLAN that is not trunked across those two controllers in some way, shape, or form, it needs to be excluded from the cluster config. In this case, I'm just going to exclude VLAN 1. I only have 2 VLANs on these controllers in Campus A. So I'm just going to exclude VLAN 1 and be done with it. I'm going to hit submit, and I'll go ahead and apply the change. And then I need to do the same thing for VMC A2. So I will assign it the Campus A cluster. I will exclude VLAN 1 and hit submit and go ahead and deploy the changes. Now I'll give this a minute or two, but if I come back to the dashboard under the Manage Network and I go at the cluster page, you can see that it's not fully loaded in yet, but you can see that I do have 2 cluster members. They are a part of 61 and 62. And so I'll give it a few minutes and hopefully that will fix itself and I'll get the graphs up and running. It does take a few minutes to establish the cluster, however. From the command line, there are some other things that you can do that we'll show you in the next video to be able to see when the cluster is established and how it's working. But for now, we're just waiting for the cluster to establish. Okay, just so you didn't have to wait a minute or two, I went ahead and paused the video when I came back. This is what you should see when the cluster is successfully established. So what we see now is we see that MCVA1 is the cluster leader, MCVA2 is a cluster member. Now there's some other bits of information that we can see from the GUI. We can click on it and we can see that the self is 61, the peer is 62, it shows connected in L2. Then we get to see some other bits of information like the round trip delay in microseconds. This is all pretty good. Remember, this is being presented in microseconds, not milliseconds. And then if you had, for example, a VLAN that was mismatching, let's say, for example, you forgot to exclude VLAN 1. And just to show you what that looks like, I'll go ahead and do that now. I'll go to config, and then we'll go to the services, the cluster profile. Let me just go ahead and remove VLAN 1. I'll hit submit. And we'll apply this change. And so what I'm essentially doing is telling this controller, as part of the cluster, you should be able to see other cluster members in VLAN 1. And I don't think that's going to work. And so what I will do is go back to the dashboard and go back to the cluster page. And now I should see, when I click on this guy, that he is L3 connected, which means that he's not doing full state and that VLAN 1 is the mismatch VLAN ID. So if I don't see the cluster in L2, then I'm not getting the full benefit of all the advanced features that I want. That just means I need to come over here and exclude VLAN 1. So I'll go to services, basically put it back, hit submit. Now once this change gets pushed to the controllers will go back into L2 state, which is where I want them to be, and then the cluster will be successfully reestablished. Now, once I have my cluster up, when we refer back to our original drawing, when I start to deploy APs at this building in Campus A, what I'm going to want to do is point the APs to this 192.168.200.60 address. This is going to be the IP address that the controllers look to, and no matter what, because it exists between these two controllers, it will always be up and ready to go. Now, we'll talk about what gets provisioned on the APs when we actually go through that process in the next few videos. But suffice it to say, you want to make sure that you create, if you want redundancy for AP discovery, that you go ahead and create one virtual IP per cluster. Even if you have 12 controllers in one cluster, you would have one VIP that would be spread across all of those controllers, or at least a few of them, so that the APs can find a controller to get provisioned to. So if you have any other questions about clustering, certainly you can read through some of the other documentation and some of the videos that are out on the internet regarding AOS 8 and clustering. But as far as how to set it up, that's really about it in the GUI. You're basically going to go to the group, you're going to go to config, go to services and cluster, you create a cluster profile, and then you assign those controllers to that cluster profile. If you have any other questions or run into any problems, certainly reach out to the online help sites like community.arubanetworks.com or reach out to your local Aruba SE or partner. Thank you.